Hello everyone, and welcome to the Clifton Gorge State Nature Preserve. My name is Madison DeWell, and I am a student at Arizona State University taking the course Environmental Communication. Today, I welcome you here to teach you about the geological processes of erosion, weathering, and deposition, and how they help to form the Clifton Gorge that we've met at today. I ask you to take this time before we start the presentation to please use the restroom, fill up your water, or grab a quick snack at the Nature Center located down this path and immediately to your right. We will meet back here in 5 minutes, and I will see you shortly. All right, everyone, welcome back. I'm glad to see that you've all returned. Let's go ahead and get started with our presentation. Our presentation will take about 10 minutes today, and we'll stay here for the entirety of its duration. Now, I have to ask, how many of you have ever visited Clifton Gorge before? Okay, a couple of you. That's awesome. If it's your first time or your millionth time here, I just want to say welcome. Clifton Gorge is a 268-acre preserve that encompasses 2 miles of the Little Miami River. It's home to hundreds of species of trees, shrubs, and wildflowers. And while all of the sites that we see around us are beautiful, none of this would be possible without erosion, weathering, and deposition. Now, this leads me to my first question. How many of you guys can recognize who this little creature is? Okay, a lot of you. Now, who wants to tell me where he's from?
Ice Age.
Yeah, that's right. He is from the Ice Age. Now, how many of you guys remember the Clifton Gorge from the Ice Age movies? Nobody? No, I'm just kidding. The Ice Age never showed the Clifton Gorge, unfortunately, but it is no stranger in geological history. Thousands of years ago, the Clifton Gorge was covered with a huge sheet of ice known as the Laurentide ice sheet. This glacier over time has split and melted, funneling meltwater released by snow and ice of the glacier full of outwash through the village of Clifton. As the water drained into the Little Miami River basin, it eroded down through the bedrock and created the precursor to the Clifton Gorge. Now, I know I'm saying a lot of terms here that you might not recognize, including erosion. So let's go ahead and get into our little demonstration and show you some of these up-close processes. We will start by looking at our setup. This sheet pan is to represent a slope and the formation of the rock, or of the land, excuse me. And the sand represents the rock that is going to be having these geological processes occur to it, and it will affect it. So during this time, I'd like to invite an audience member up and ask if you'd like to help me. Oh, awesome, come on up. All right, you can go ahead and join me on this side of the picnic table, please. Thank you so much. What is your name?
Nate.
Nate, it's nice to meet you. Thank you for coming up here. You are going to act as the water that is going to be flowing down the rock and causing the geological processes to occur. First, I'm going to have you carve with your finger a little narrow riverbed through the sand. Awesome, yeah, just move that away to the side. Perfect. So how we can look at this is as the Little Miami River that flows through the gorge. As we said, it's about a 2-mile stretch. At the top here, we're going to have you pour the water. This water can represent a river, a stream, rainfall, any sort of precipitation, that can cause the processes to occur. So let's go ahead and start up here. I do want to mention there are ice cubes up at the top. These are going to represent the glaciers that were present during the Ice Age, and we will try to observe what they are showing us, but if not, we will go over it at the end. So let's go ahead and start. I'll have you pour the water at the very top of the pan. Awesome. Now, what are we seeing as the water is flowing through this channel?
It's kind of breaking down the bank and taking,
Yeah, so this is the process of weathering. It's going to break down or dissolve the rock over time. This can be very gradual, and it occurs over time and will change the shape of the rock, including the riverbed. The glaciers, as we talked about during the Ice Age, definitely played a role in carving the riverbed as it funneled that meltwater. We can think of this as some meltwater, if you would, this being the outwash. Now, what do you see in all of this that is carried down through the river?
It's kind of carrying the rocks down the
Yeah,
slope
so there's
with
a
it.
lot of rocks in it. Yeah, so this is going to be the product of erosion. We'll go over this a little bit more in a moment, but erosion is the transportation of rock as it's broken down and just any sort of sediment. As it's broken down, moved, and this can happen through wind, and it can also happen through water. Now, let's pour just a little bit more. Try to go just a little bit below where you poured last time. Yeah, so we see this carrying down to the bottom of the pan. And what is it doing once it gets down there?
It's carrying all the rock down there, and then it's just leaving it at the bottom of the slope.
Yeah, so we can define this as deposition. And deposition occurs when the sediments are transported from one place that they originally were to another where they were not. The rocks exposed in the gorge were sediments that were once deposited around 445 to 430 million years ago as the sea levels continued to rise and fall. These changing sea levels ultimately led to layers of limestone, dolostone, and shale. And we talked about these ice cubes up here representing glaciers. Did we see any change?
Not really.
Not really. But over time, in real life, we would see these melt and they would weather the rock underneath it, erode the rock by lifting it up and transporting it down. It would cause deposition of these big chunks of rock from the glaciers that would sit at the bottom, which has helped cause a lot of the rock that we see here in the Clifton Gorge. Thank you so much for your participation. Do you have any other questions or anything?
No, I don't think so.
Okay, awesome. Thank you so much. You can go ahead and rejoin the audience.
Thank you.
Thank you.
All right, I just want to say thank you so much, Nate, again for coming up and helping us with this demonstration. Now, while we've seen these geological processes in action, let's talk a little bit more about some rock types that are found in the gorge and how erosion has played a part on them. The first rock that I want to start out by talking about is shale. The shale found in the Clifton Gorge was compacted over time by muddy sediment that eroded from the highlands and that was deposited where we are now in southwestern Ohio. Shale is highly erodible and oftentimes can help to create a slippery slope. I'm going to pass this one to you, and you can pass that around, take a look at it, make sure to really look at the layers and how it is eroded over time. The second rock that we are going to discuss is dolomite. Dolomite is obviously not as eroded as what that shale picture is. This is a very tough rock. It's very hard to get this to break down. It is extremely gradual and it is very heavy. So what this means for us here in the Clifton Gorge is that the dolomite rock that sits on top of shale over time has slid down the slope and has created what we can call slump blocks. Now, while I grab my diagram for that, I will pass this one to you as well, and you can go ahead and compare and contrast those two rocks. Now, when I say slump block, what are you thinking? I wouldn't really know what to think either. This is what I am talking about. So in this diagram, we can see the slump itself, and in our case, the shale rock would be what is creating the slippery slope, and the dolomite rock that has sat on top of there has eroded and came down the slope and deposited at the bottom of the riverbed. There are plenty of slump blocks that show this in the gorge. You can see them all along the trail. But this is the main feature of it. Now, there are slump blocks that can be found all over the trail. One of the most popular is the steamboat rock. Let me grab this for you. Here's a diagram of the slump blocks that can be found. These are just a couple of examples, as you can see them located everywhere. You can see slump blocks on the side that have been eroded over time and are very uneven. And we see steamboat rock, which I just mentioned, that is very popular here and was created thousands of years ago. Over time, it has eroded it has been weathered, which has caused the erosion, to cause this steamboat shape that actually looks like a little boat itself. I do have another image for you as well to show the shape of that rock. You can see how it models a little boat, or in this case, a steamboat, and it is very large but very uneven. We can see here another little slump block that has deposited at the bottom from sliding down the shale and with the dolomite going down. Now, we've talked about dolomite, and I just want to point out that Steamboat Rock is Cedarville dolomite, which is pretty cool considering we are right around Cedarville and the village of Clifton. So, the rocks that we have talked about today have helped provide the water of the Little Miami River flow through and create the amazing gorge. Without the weathering, erosion, and deposition of rock here in Clifton Gorge, the park may contain a waterfall. Without rock breaking over time, the water would go straight and down. As in our gorge, our walls are very steep and narrow, and so it allows the water to flow straight down the center. So, with that being said, I hope that you have a better understanding of how erosion, weathering, and deposition have occurred in the Clifton Gorge and how it has helped shape the environment of the park. I invite you to please explore the 4 trails here at the Clifton Gorge, including the Gorge Trail, the Rim Trail, the Orton Trail, and the Narrows Trail. I do caution you to be careful with your footing. It is a very wet day. It has been raining all day here in Clifton, Ohio. There are some cliffs that are present on the trail. You just want to make sure that you're staying within the fence, you're staying on that trail, and you're being safe about where you are stepping. I don't want any of you to get hurt. Now, I will be here for another 15 minutes. I do have an exit survey provided for you. In my binder, I have a box of pens for you to use. Should only take about 5 minutes and will help me with getting feedback for future presentations here at the Clifton Gorge. With that being said, again, I will be here for another 15 minutes for any other questions, comments, or concerns. And I just want to thank you again for joining me here. And I hope you have a great rest of your day and stay safe.